This is exercise 7.3 from Introducing the Theory of Computation by Wayne Goddard. And exercise 7.3 is construct a PDA for the language of strings of the form 0 to the n, 1, 0 to the n. So that's what this machine here does. We start in state 1 and epsilon transition to state 2. And when we do that, we push a delta onto our stack. From state 2, every time we read a 0, we're going to push an x onto our stack. Once we read a 1, we'll transition to state 3. From state 3, every time we read a 0, we're going to pop an x off our stack. And once we reach the end of our stack, we're going to pop off our delta placeholder and move to state 4. So let's take a look at that in Python. Here's our collection of states. Our machine 7.3 takes a string as an input, and L breaks our string into a list of characters. POS is the position in the string that we're evaluating, so the next symbol that's being read. S is our start state. It gets set to state 1, or S is our current state, rather. It gets set to state 1 at the beginning here, our start state. Our stack is a Python deck. Our result is set to false at the beginning. So this check here is not really necessary, but it better emulates how the machine actually works. So if we're in state 1, we'll always be in state 1 at the beginning here. We just move to state 2 and push a delta onto our stack. We use the dex append method here. So while our position counter is less than the length of L, so while we still have characters in L to evaluate, we're going to do these checks here. So if we're in state 2 and we read a 0, we're going to push an X onto our stack and increase our position to read the next character. And this continue kicks us back to the beginning of the loop. So if we're in state 2 and we read a 1, we're going to transition to state 3 and then increase our position counter and go back to the beginning of the loop. So if we're in state 3 and we read a 0 and stack minus 1 is equal to x, so that means that the top of our stack has an x. We're going to pop the x off the stack, and our position will increase and will continue. And if we're in state 3 and these two conditions aren't met, we read a 1 or we don't have an x at the top of our stack, we're going to break out of this loop because that's not a valid string. So at the end of our loop, that is after position is equal to the length of L, so we've evaluated every position, we're going to make sure that S is equal to state 3, and the top of our stack has a delta, and we've evaluated every position in our string. So we'll pop that delta off of our stack and move to state 4. And if we're in state 4 at the end here, we set our result to true and return that result. So here's a couple example strings. These first 4 are in the form 0 to the n, 1, 0 to the n, and the next 4 are not. So it should return 4 trues and then 4 falses. And there we go. That's 7.3.